today in class we talked about the 5 factors that influence the rate of a chemical reaction. And the first one is temperature. We learned that the higher the temperature, the faster the reaction will go. So in these 2 beakers, I have a hot beaker and a cold beaker. Using 2 identical pieces of Alka-Seltzer, we're going to see which reaction happens faster, the one in the hot beaker or the one in the cold beaker. So ready, set, go. So right now we can see that this is bubbling more violently, and this one's kind of just bubbling normally. And it appears now that this is done reacting, and this one is still going. So the rule is proved where the hot one, so the higher temperature, that one reacted faster. The next reaction factor we're going to look at is particle size. So the rule says the smaller the surface area, the bigger the surface area, so the smaller pieces we have, the faster the reaction will go. So I have crushed Alka-Seltzer and whole Alka-Seltzer. So we're going to dump each of them in at the same time. And it looks like the crushed Alka-Seltzer reacted faster because it had more surface area, which means we had smaller pieces, while this one is still going. If you've ever used hydrogen peroxide to clean a cut, you'll know that it kind of bubbles and stings. Well, in the stores, you can buy 3% hydrogen peroxide, and we use 30%. 30% is 10 times more concentrated than 3%. So this reaction factor is concentration. Now what happens, the reason that hydrogen peroxide is kept in a brown bottle is that hydrogen peroxide reacts with light. So H2O2 will break down into H2O plus O2. So if we dump a little 3% into an Erlenmeyer flask, we'll see that reacts just a little bit. We'll see some bubbles happening because of that oxygen. But if we pour some 30% into an Erlenmeyer flask, we'll see that it reacts even more. The higher the concentration of a solution, the more fast it will react. But we don't really want to wait for this to react all day, so what we're going to add is a catalyst, and we're going to add manganese dioxide. So if I add just a little spoon tipful of manganese to the 3%, we're going to see some gas forming at the bottom. This is our oxygen, and the smoke is our oxygen as well. After this is done reacting, it'll be water left at the bottom. This is 3%. Now we're going to put the same amount of manganese dioxide into the 30%. So what happened here is that the catalyst sped up the decomposition of hydrogen peroxide. So with our 3%, we had kind of a little reaction. But with our 30%, we had a really, really big reaction because the 30% is more concentrated. So we had a little bit of O2 with the 3% and a lot of O2 with the 30%. In order to find out more about inhibitors with penicillin, you should look at the YouTube video on the class website.